Hi, welcome back to 6.3. We're going to work on dividing polynomials. And one of the things we have to go back to is the idea of long division of what we did. Kind of remember that system of, we said back in here, we said, okay, how many, if you're taking 277 divided by 12, you'd say, all right, how many times does 12 go into 27? You'd say 2. 2 times 12 is 24. We'd subtract and get a 3. Then we'd bring the 7 down, have 37, then we'd say, all right, 3 times 12 is 36, and then we'd be left with a remainder. Kind of a thing of long division. We'll do the same thing with polynomials, and we'll kind of walk through some examples here as we go. All right, so if we use this for long division, okay, what we're going to do is we're going to take this. This is going to be what's outside, y minus 3. And then make sure you put it in standard polynomial form. So rewrite it as 2y to the third minus y squared. Good idea to maybe fill in a 0y right there, just because there's no y term, and just have a place value. I think that's a good idea to do that as well. So we're going to go ahead and we're going to write it in that way. All right, and then what we're going to do is we're going to divide. So we have to think, all right, well, how many times, what do we have to multiply y by to get 2y to the third power? Well, that's going to be 2y squared, isn't it? Yeah, so again, that's what we're going to get there. So let's take the 2y squared times, all right, and we got to take it not only times the y, but also the negative 3, so we end up getting the 6y squared. Now we have to subtract that. All right, and this is where mistakes are going to be made. So when we subtract that, we're going to get a positive 5y squared, and then what we're going to do is we're going to bring down that to the next spot. So now we think, what do we have to multiply y by to get 5y squared? Well, 5y. So then multiply that not only by the y, but also the negative 3. So now we're going to subtract that. That's, those are gone. That's why we did it. Now if we go 0 minus a negative, that turns into positive 15y. And then we bring down the 25. And then, well, what do you have to multiply y by? What do we multiply y by to get 15y? Well, that's going to be positive 15. And as it turns out, we get negative 15 when we subtract. All right, those are gone. 25 minus a negative, well, okay, you kind of see there that ends up being 70 is the remainder. Okay, things don't always divide in equally, so we write our final answer. Now, you'll see it written like this. Basically, you take the remainder divided by the y minus 3. You can also think of that as a remainder of 70. Sometimes we write it like that as well. Okay, so let's go through one of these ourselves here and get it all set up. So let's take the 3x plus 1. That's going to be what we have outside here. We're going to divide that into 15x squared plus 8x minus 12. Okay, that's a squared right there, yeah. All right, so we have to right away think, what's 3x times what gives us 15x squared? All right, well, that's going to be a 5x. So 5x times 13x is 15x squared, just like we designed it. But then we also have to multiply it by the 1, and so we get plus 5x. All right, now we subtract. Those are gone. 8x minus 5x is 3x. And then we have a minus 12. Start the whole process over. Well, in order to get a 3x, to be a 3x, we're just going to multiply it by 1. So we get a 3x. 1 times 1 is 1. We subtract, those are gone. Negative 12 minus 1 is negative 13, so that's the remainder. So we could say a couple ways. We could say 5x plus 1 with a remainder of negative 13. Or the other way to write that is our answer is 5x plus 1. And then minus, because it's a negative, we could go 13 over what we're dividing by, 3x plus 1. Those are two different answers, choices that you have. So there's long division. Barf, right? There's got to be an easier way. And there is. There's something called synthetic division. Okay, and here's going to be the process. And again, I'll walk you through that as we go here. All right, so to do the long division, or synthetic division, here's what we're going to do. X plus 2. We're going to put in the x value in the magic box. We're going to set it up to call that the magic box. What value of x would make that 0? Well, if that's plus 2, the opposite's negative 2, that would make that 0. And now what we do is we write our coefficients across. We start with 3. Then there's a negative 1. Now here's a tricky part. There's not an x squared term, so we have to put a 0 because it's 0x squared. Then there's a 5. Whoops. 5, and then there's a -1. And this will be the remainder box. Whatever's in that box will be the remainder. All right, so we got to think like Snoop Dogg right now. We're going to take this first number 3, and we're going to be like Snoop Dogg. We're going to drop it like it's hot. There it is, 3. We take -2 times 3. It's going to be -6. We add those together to get -7. Then what we're going to do is we're going to take -2 times -7, which is 14. We're going to add those together. That's 14. -2 times -14 is -28. Add those together, that's -23. -2 times -23 is positive 46, and if we add that to -1, our remainder is 45. So as we go back and write this down, now that's the remainder. That's what the remainder is. This is the constant, this is the x squared, and this is the x to the third. So our final answer is going to be 3x to the third minus 7x squared plus 14x minus 23 with a remainder of 45. Or if you want to rewrite it, you could say plus 45 divided by x plus 2. Or you could do the remainder of 45 if you wanted to as well. Okay, be ready for either type. All right, there we go. Let's try another one. This one's a little easier. All right, so we start with the magic box. We look and say, okay, what value of x would make that 0? It's going to be 6. Then we put our coefficients 1, -3, -18. A little shorter one here. That's our remainder box. We're going to take the 1, drop it like it's hot. 6 times 1 is 6. Add those together, we get 3. 6 times 3 is 18. Oh, look at that. No remainder. It divides unequally. Remember, that's our constant. That's the x. So our final answer is just going to be, hey, the answer is x plus 3. I like that. That's kind of nice. Not too bad. Yeah, I get the hang of it. All right, now, another thing is that we have this remainder theorem, this saying that, if you actually go through the synthetic division process, and if you go through the process and you have a remainder here, that is the same number as if we were to take 3 and put that in for x on all of those. And if we were to figure that out, we would actually get 7. That would actually be the same as doing the answer there. So we kind of this method is called synthetic substitution. All right. So here we go. Here's how it would work. We're going to do it for x equals 2. So we're going to put 2 in the box. We've got 2, 5, -1, and 7 up there as we do our synthetic division. Here we go. Drop the 2 like it's hot. 2 times 2 is 4. Add them together, you get 9. 2 times 9 is 18. Add those together, you get 17. 2 times 17 is 34. And if you add those together, we get 41 in the remainder box. So what that means, it means that if I were to take and put 2 in for x and evaluate the function, I would get 41. Isn't that weird? Yeah, it's the same thing. If I were to actually put a 2 in there, it actually is the same thing. Crazy kooky, but it's true. All right, so let's try to do this one all on our own here. Let's see what happens here. Let's put -3 into the box. We have 1, 3. Oh, no x terms, so make sure to put a 0. That's where people make a mistake. Be careful. All right, so now our answer, if we were to put -3 in for x, it's going to be the same thing as what we get in that box. Let's take the 1, drop it like it's hot. -3 times 1 is -3, which gives us 0. Anything times 0 is 0, which gives us 0. That's 0 right there. And let's see, there we go. We get 4. So p of -3 is 4. That'd be the same thing as putting -3 in for x. You would get the answer of 4, which is crazy kooky, but true. It works.